So now we're going to talk about the two different ways that you can solve a system of two equations using algebra instead of graphing. So there are two methods. The first one we're going to talk about is solving systems by substitution. The idea with substitution is you're going to solve for one of the variables in one of the equations and then substitute what that variable is equal to in the other equation. So the way we do that is we solve for one of the two, solve one of the two equations for one variable. And what that really means is that you're going to get one of the variables by itself on one side. That's what it means to solve for one of the variables. You get that variable all by itself. Then you're going to substitute the expression for this variable, whatever was on the other side of the equal sign, into the second equation or the other equation. Once you do that, you'll only have one variable left in your resulting equation, so you're going to solve that. And then you're going to substitute that number that you just got back into one of the original equations and find the other variable. So that's going to be your ordered pair, as long as there is a solution. It's never a bad idea to check your solutions in both equations. You don't have to show it on paper, but at least doing it mentally, particularly if you're in a testing assessment situation in class, double check, did I get that right? You can catch a lot of small errors when, you drop a negative or forget, add wrong. You can catch a lot of those errors by checking and going, wait, it doesn't work, and then retrying your original solution. So it's a good piece of advice. Okay, so we're going to go ahead and solve this first system on the left by substitution together. So the first thing I need to do is get one of the variables in these equations by itself. And when you look at it, you can tell there's kind of a variable that stands out. I guess you could do the x, but that would take an extra step. If you just get the y by itself, all you have to do is add the x over. So that is probably the most efficient first step you could choose. And this is why the substitution method works best when you have a situation like this, where the x or the y in one of the equations is either just a 1x or a 1y or possibly a negative x, because that makes it easy to solve without a lot of fractions. So now what we're going to do is we're going to go to the other equation. And since we got the y by itself here, I'm going to take the y. I'm just going to make this a little bit bigger. I'm going to take the y in the second equation and I'm going to substitute into that equation what the y is equal to. So everything else in that equation is going to stay the same. It's still 2x minus 5y equals 1, but the y is going to be taking its equal form, which is 5 plus x. So now you have to solve that equation for x because it's the only variable left. So I'm going to go ahead and distribute my negative 5. I'll add those x's together. Move the 25 to the other side. And divide. So now I have half of my solution. I have that x is equal to negative 26 over 3. And I need to find the y that goes with that. So I'm going to do another substitution. Up here I have that y is equal to 5 plus x. So I'm just going to substitute in what the x is. I guess I could write it as minus 26 over 3, considering it's plus a negative. And then just a quick fraction conversion there. 5 is 15 thirds. So 15 thirds minus 26 thirds is negative 11 thirds. And so my xy ordered pair solution for this system is negative 26 over 3 minus 11 over 3. Now, if I was in, like I said, a test situation, I'd probably plug those in. Since they're fractions, I probably would need to do it on a piece of paper, just to double check to make sure I've got that right. So now I want you to give it a try. Come on over here to the second system that we have and work on solving that by substitution. Go ahead and pause the video and work on that and then start it up again. Okay, how did it go? So again, I chose actually in this one to get the y in the second equation by itself, but now that I look at it, probably would have been a little easier to get the x by itself. Either one. The whole idea is to pick the one that has either a 1 or a -1 as what you're going to solve for, because otherwise you're going to have to divide by 2 or 3 and then make a fraction. That's going to be more work than it's worth. So you probably thought smarter than I did and did x equals 8 minus 3y and then substituted that in here. I went a slightly longer route, took me 2 steps to get my y by itself, and then I substituted that back into the top equation for y. Ended up with x equals 5, substituted that back in and got y equals 1. And I did mentally, just quickly, since they're not fractions, double check my answers here, and it did work out. So even if you did it a different way and solved for x, you should have the same ordered pair solution at the end. So that is our substitution method.